Good afternoon, everyone. I'm Irfan Siddiqui, and it's an absolute pleasure and honor to welcome you to the fall 24-25 academic semester as the chair of the Department of Physics. I hope you all had a very productive, yet restful, yet travel-filled, yet staying-at-home summer, however physicists are able to balance all of those things, and that you're ready and back in the department with a sense of excitement and ready to run with all cylinders fired for the year that's coming up. I want to start with a tradition that we've had for many years in the physics department, which is to look at the year that's gone past in photographs. Okay? And with that, I owe many thanks to Sarah Whitmer, who is still with us with her camera, for taking many of the pictures that you'll see. Not only is she a wonderful photographer, she is also the composer of the slideshow that we'll see in a moment. And I also want to acknowledge the flutist, whose accompaniment you will see with this particular presentation, Vidnashri Vastana, and his YouTube coordinates are there, and this is taken from one of his recent pieces. Now's our chance for this year to fill up Sarah's cache of new photos. Let's have a round of applause for Sarah. This slide seems to always be in vogue, and it's no surprise to anyone that our department remains at the very forefront of so many fields of physics, looking at advancements from the very microscopic, smaller than an atom, smaller than a particle, to that which is very grandiose, whether it be a star or a black hole, or things even entangled across the entire universe. what I wish to share with you in the next few slides are some of the highlights that we have of the wonderful science coming through the doors of UC Berkeley and Lawrence Berkeley National Laboratory, two entities that are joined at the hip. They're also staffed at the moment in the beginning, in the front of the lecture. Advances in neutrino detection. You know, for a measurement person, neutrinos represent a real challenge. They really don't want to talk to anyone. They really don't want to interact with anything. They kind of want to do their own thing. And what's particularly exciting at the moment in the world of neutrinos, vis-a-vis the intersection with UC Berkeley, is really the first light or the dawn of a new detector named EOS, after a god that has that particular symbolism with a new dawn. And what you're seeing on the right is an array of photomultiplier tubes around a cylindrical scintillator, which is 10 meters tall, 5 meters wide. And what happens here, as these neutrinos have electronic interactions, they excite this organic scintillator, and in fact emits light which can be detected. Moreover, something I find very interesting is that the electrons which are also produced kind of produce almost a sonic boom. They are traveling faster through the scintillator than, in fact, the speed of light through that medium. So that little sonic boom creates a comb which allows it to also have some spatial understanding of where the origin of this source is. Did I get it right? Pretty close, very good. That was the shiny version. But nonetheless, this is something that's been developed here and has recently seen first light. So I think this is tremendously exciting. The scintillator piece is busy. I'm asking Dan because we were both in the same lab. Him as a graduate student, me as an undergraduate finish up, and I was working on scintillators detecting neutrons. Light transforming insulating materials. So the chemists in the audience are extremely familiar with the idea that changing an atom here or there goes ahead and changes completely the properties of a material. Sodium, for example, is a metal you should never put in air. If you do, you may have many stories to tell about that. But if you add it with chlorine, then you get table salt, without which your food doesn't have taste. So you completely change the properties by chemistry. Here, the group at UC Berkeley and LBNL changes the conduction properties, where in fact something which looks almost metallic can be turned into insulator by very fast pulses of light. And you can imagine the technological implications of that, where we think about making switches or computing devices, which on a very, very rapid time scale can be switched from one state to the other using laser beams. Okay. Professor Kolkowitz is here. So he's not happy with just breaking world records for sensing with atomic clocks. He wants to go even beyond that. And in this particular idea is the fact that you can imagine taking an atomic cloud, okay, and nature's atoms are rather identical with respect to each other. They can be used for a variety of metrology applications. But one, of course, then worries about noise, right, in particular common mode noise, from the environment that can push your cloud up or down. Whereas if one thinks about breaking that cloud up into 3 or 4 or 5 little clouds of atoms, you can measure all of them separately and, in fact, measure differences. Right? And that differential mode allows you to push sensitivity even further. This I got right, yes? Very good. Quantum stuff I will get right. Okay, then we move on to ideas that go from this cloud to a much bigger cloud, right, which perhaps is in a black hole. And black holes, for me, are fantastic and experimentalist, because I think about absolutely no experiment I can do on a black hole, in a black hole, around a black hole. I'm totally immune from this particular subject. However, there are interesting ideas that come up on the theory side of what happens to the information in a black hole. And in particular, there's this long debate, of course, with Hawking of whether information is conserved or not conserved and where it goes. And in particular, the idea that the information is radiated away in Hawking radiation. And some years ago, with faculty members here, we did an experiment to think about the scrambling, saying that information which is scrambled or quote-unquote randomized in a black hole somehow is leaked out through this channel of Hawking radiation, can be reconstructed. This particular work is very interesting because it says there's a little bulge on the black hole. So there may be something that goes a little bit outside of the usual horizon of the black hole, and maybe one can probe it. And in particular, if you probe the little bulge, maybe you understand something about something that fell in the hole. So I read this and I was just tremendously excited. I said, good, now we can do an experiment, outside the black hole. If I understood correctly, the first experiment, the length or the extent of this penetration is extremely small, probably on the scale of the smallest thing that one can even conceive of writing down with letters. So this is sort of a tall task. However, there's a tremendous breakthrough that says, yes, now we have this information. It is the size of an atom. It comes out of the hole. So I feel much more reassured. So all graduate students here, the task now is to measure one atom outside of the black hole. Next year, we will present your result here. So, moving forward, again, in this idea of having information being shuttled on small length scales and large length scales in the quantum, there is this beautiful work coming out showing us that antiferromagnets, where spins, in fact, anti-align into a rather rigid structure, can, in fact, be very good conduits of quantum information over long distances. And indeed, magnetic excitations are much longer lived because they are not perturbed by electrons. They are not perturbed by monopoles. Typically, all of these excitations are like little bar magnets or dipoles, unless you're at Stanford, in which case, every once in a while, they're a monopole. I'll let that be. Okay. Sorry, Steve. Speaking of Steve, speaking of Steve, you are mentioned in this slide. So this one really caught my eye. It's an amazing idea. How many of you have seen the Aurora Borealis? A show of hands. Yeah, I tried to find this in Canada, up in the north. I almost gored by a moose, but I didn't see the aurora. It's very dangerous. It's another story. But nonetheless, apparently there's an aurora, and then there's these things which are like little bushes, which are called steves. And there are picket fences next to the steves. And for the life of me, I couldn't figure that out. So I actually had to go do some research. Apparently, it is a reference to a scary bush in some 2006 movie. Hey, I don't make this stuff up. How many of you knew that reference to steves? And all right, very good. Very good. Tomorrow afterwards, we will have to have a small discussion of this. But digging deeper into this, in fact, they may look like shining lights, and they are all like this, but in fact, they're very different, perhaps, in origin. The standard aurora that you see is due to solar activity, which is coming down, energizing particles in the upper magnetosphere, and they're following some trajectories along the magnetic field, because that's the interaction that they have. Okay. This particular case says that maybe you also have an electric field. The electric field could be parallel to that magnetic field. That's not normally a situation that you would have in ENM, but there may be pockets where you have more insulating behavior, and you can generate this electric field, and they would generate, Jeff, picket fences and steves. Very good. And this was really done by students here. In fact, a student here. So it's tremendous. Sending quantum information, again on the same theme of exchanging information. One has the idea that if I have a quantum computer here, say, maybe one up at LBNL, could they talk to each other? And in fact, how would they talk to each other? Because the type of information you want to send is entanglement. And that's a very non-trivial task. In fact, producing this entanglement and maintaining it even within the realm of your own laboratory is very difficult. However, we have this particular utility of the photon. Right? So if we are able to entangle with photons, they are rather inactive with respect to their environment or other things that they may want to entangle with. So this project is a tremendous step forward, trying to take quantum information from one particular system, encoding that in some flavor of photon, and then sending it over an exton distance. And in this particular case, we may be sending information to ourselves. I don't suggest that you two use this method to communicate. It's much faster sitting next to each other. But we may be able to use the fiber that's embedded and controlled by a lot of the LBNL researchers to actually send this quantum information across distances. And if it works really well, we'll send a secret message to Stanford. And of course, sort of rounding it out, where is the field going? I don't know, where is the field going? So we thank our researchers that are here, in particular, one researcher, in fact, who headed this international effort to really figure out what the future of particle physics should look like. I imagine it's bright, it's got a lot of scattering in it, and so on and so forth. But again, showing you the mark of Berkeley scientists, starting at home, starting with our students, radiating outward, both between the institutions that are here, and then really radiating out to the world as we know it. A lot of these advancements are really a team effort, and they're made possible through the various centers that we have, scientific centers that we have on campus, and I just want to thumb through a few of them. So there is the Vibrant N3AS Center, which looks at the theory and computation for multi-messenger astrophysics, looking at fundamental symmetries, nucleosynthesis, dense matter and neutron stars, dark matter, and various other astrophysical situations. There is the CIQC, the Challenge Institute for Quantum Computation. And you can imagine a lot of the things I was mentioning are really far-reaching technologies. How one encodes quantum information, how one saves it, how one sends it, so on and so forth. So in a nutshell, you see the text there. I would say this center is really looking at the science of how to wire up entanglement. Okay. And that's a real challenge. because if you touch entanglement, you get entangled with it, and that's a problem for your computer. Okay. At the same time, there are other centers, such as the Advanced Quantum Testbed and also the Quantum Systems Accelerator up at LBL, that think about radiating beyond that. If I now have some modality to actually encode and transmit and process quantum information, what can I do with a machine that's a prototype? And again, trying to put a very soundbite on this, really the science of quantum information processing, quantum computing, was given a shot in the arm, so to speak, when we figured out that perhaps you can factor numbers much more efficiently than any classical technology. The problem was you needed a perfect quantum computer for doing this. So in the absence of a perfect quantum computer, we need to figure out what do you do with imperfect quantum computers. Right? And that's an entire science in and of itself, and the subject of many of these centers. Okay. This is perhaps one of my favorite ones, the BCTP. Okay. They are probing the most pressing scientific questions of the universe. So what are those most pressing scientific questions? This is another evergreen slide because there will always be pressing questions of the universe. But at the moment, they are thinking about particle theory, cosmology, string theory, and quantum gravity. And in fact, on the left side, you have the different topics that intersect with that particular set of topics, the Higgs boson, the multiverse, and the like. Okay. There are centers that radiate beyond our borders. Right? Certainly the Quantum Systems Accelerator, the NSF centers, go beyond Berkeley. But here's one which is UC-wide that looks at the physics of the electron-ion collider and looks at these particular questions on the right. You know, how does the mass of protons and neutrons arise from the nearly massless quarks and gluons? How do you get something from nothing? I don't know. You will tell us at some point. Okay. How does the spin of the nucleon arise? Okay. And what are the emergent properties of dense systems of gluons? And you can see the synergy between Berkeley scientists. Once you tell us why the spin arises, another professor will transmit it through the insulators, and yet another one will turn it off using light. Right? So we have, in fact, all of those elements present here. Okay. And again, this intersects with all of the research done both at the graduate and undergraduate level. There are programs where both our students who are matriculated here at Berkeley and those that are visiting can intersect with all of this cutting-edge science. And those programs, some of them at least, are enumerated here with at BPI at the top, where this is the Berkeley Physics International Education Program, and that partners with universities around the world to provide undergraduates, international students with an opportunity to study here at UC Berkeley. There's Beta Physics, right? The Berkeley Experience and Training in Advanced Physics program. It's a certificate non-degree program which hosts visiting students from around the country and around the world. The Berkeley Pre-Core Transfer Summer Program, RAISE, Berkeley Connect Physics, Pi Squared, and others. So there are many things happening at any given day in the research landscape here at UC Berkeley. Okay. Things that are slightly different that were done in the fall, something very recent. So I want to highlight that the undergraduate research fair, which happened for many years in the physics department, this year was extended across the division, right? And it took place now in Pauley Ballroom. Before it used to be in Stanley, I think, right? But now we've expanded to Pauley Ballroom, and it was a tremendously well attended by both researchers and young students, and there was real vibrancy there. So I wanted to highlight that particular event. And the departments that participated were astronomy, mathematics, EPS, MPS scholars, and Pi Squared scholars. And again, going back to not only the researchers, the community as a whole, we have elements that are made up of the faculty, of our administrators, who spend many, many hours making this department run and really being the glue in this entire department. Okay? And we have scholars and students. And this is really a very vibrant community. And I want to introduce you to some of the newest members of this community. So this is Professor Luca Ilieso, who joined us in the middle of the year. And he is a high-energy theorist interested in quantum field theory, quantum gravity, and their relation to particle and condensed matter physics. He was recently honored with the Fundamental Science Award and the DOE Early Career Award. And he has this quote, which I will call upon him perhaps to either read the quote and add his own words here. Luca Ilieso, you are here somewhere. Good. Please rise.
Well, I won't read the quote.
We should read the quote. Welcome, Luca. And before I show the next 4 slides, I really want to start off by thanking an entire village that made the season of hiring new faculty members in this department possible last semester. And this was really a real joint effort at all levels between the faculty in this department, the search committees, the students that served on those committees, and then, of course, moving on to the Dean of Mathematical and Physical Sciences, the Vice Provost for the faculty, the Executive Vice Chancellor and Provost, and also the Deputy Director of Lawrence Berkeley Laboratory. Okay. All of these entities coming together and saying, we want to hire the most talented physicists and bring them into this ecosystem. So they will be joining us at various times. So I have their slides here. I also have some very short sound bites from them. I will read their slides in their absence. So to start off with, we welcome Aziza Suleimanzadeh to the department. She is an experimental physicist working with Rydberg atoms, superconducting circuits, diamond nanophotonics. And in particular, she developed a novel platform for transducing quantum information and demonstrated entanglement distribution between spin qubits over 40 kilometers. And she says she enjoys finding creative ways to control new quantum degrees of freedom and generate exotic states of matter and life for quantum information technology and precision measurements.
Hello, my name is Aziza. I'm an incoming assistant professor in quantum experiment. My start date is in July 2025. I'm really excited to join Berkeley and get to know everyone. In the meantime, if you have any questions or just want to say hi, please reach out. Cheers.
Okay, so we look forward to welcoming Aziza when she's here. We have Harry Levine. His research is in experimental quantum science. In particular, he did seminal work in the development of Rydberg simulators that are used for quantum information processing and simulation. And he is excited about developing new strategies to control quantum systems in the lab with ever-increasing scale and fidelity.
Hi, I'm Harry Levine, and I'm going to be joining the physics department as an assistant professor in the summer of 2025. I'm thrilled to be joining the department, and I can't wait to meet you all.
We have Victoria Zhu, who I think many of us may have interacted in different ways. And I remember my first interaction with Victoria is that she was an RAU student in our lab. And then she decided to stay here at UC Berkeley to pursue a PhD, and then went on to do beautiful work with the LIGO collaboration. And so she works on precision experiments for fundamental physics. She was awarded the Hensch Prize for using quantum optics to fundamentally improve metrology and advanced gravitational wave detection. She's interested in using precision measurements to more deeply understand and observe our universe.
Hi everyone, I'm Vicki. I'm really excited to be going back. We just moved out of Cambridge this last weekend, and I'll be at the LIGO observatories over the fall, and then I'll see you all in January when I start. Bye.
All right, I apologize for all the snarky remarks about Stanford. Finally, we have Professor Chiara Salemi, and she is an experimentalist who has developed new techniques to search for axion dark matter, which I'm told is everywhere, but somehow we cannot find it. But apparently she will find it in a set of experiments. And my research combines superconducting quantum sensors, classical electromagnetism, and high-energy magnets to search for axion dark matter.
Hi, Berkeley Physics. My name is Chiara Salemi. I build experiments to search for axion dark matter using quantum sensors. I'm really excited to join your community in January.
And so she's currently at Stanford, but has decided to come here. No further comment needed. We have others that have been honored and are joining us in our community. In particular, we are always grateful to the Miller Institute for funding postdocs and visiting professors and scholars. And this year we have the pleasure of welcoming Marina Phillip from the University of Oxford, Vidya Madhavan from the University of Illinois at Urbana-Champaign, and Nicolas Pauldin from ETH Zurich as visiting professors, and as fellows, Catherine Frazier from the American University of Beirut in Lebanon, and Kate Reedy from Trinity College in Dublin. These are our Miller scholars. And our faculty continue to win awards. And apologies if I missed any one of the awards that have just happened, or simply because we've missed them. So James Analytis, Professor Analytis, has won the Brown Investigator Baker Prize and LNS Faculty Award. Mina Aganacic, the Miller Fellowship. Rafael Busso, the Miller Professorship. Anand Garcia, the LNS Faculty Award. Wick Haxton, the American Philosophical Society. Professor Shimon Kolkowitz, the Moore Foundation Experimental Physics Investigators Initiative. Holger Mueller, who is also a Brown investigator. Hitoshi Murayama, Miller Senior Fellowship. Professor Gabriel Rubigan, the ICFA Instrumentation Award, Professor Jeff Pennington, the Sloan Fellowship, APS George E. Valley Junior Prize, Ramamurthy Ramesh for his election to the National Academy of Arts and Sciences, Uro Selyak and Irfan Siddiqui were elected to the American Academy of Arts and Sciences. Third person, Feng Wang was a recipient of the APS Frank Isaacson Prize. So congratulations to these faculty winners. And this brings us to a very particular part of the presentation where we're going to honor one of our own very beloved colleagues with a very special award. Okay. This is the Berkeley Citation. This goes to Professor Steve Louie, okay, and one of the quotes from the various folks that contributed to the nomination. You're on a leash, sir. Steve's career is a wonderful example of how UC Berkeley attracts exceptionally talented people and develops them into world-class scholars. The Berkeley Citation is awarded to a variety of distinguished individuals or organizations, academic or non-academic, whose contributions to UC Berkeley go beyond the call of duty and whose achievements exceed the standards of excellence in their fields. To present the award to Professor Louie is the Dean of Mathematical and Physical Sciences, Professor Steve Kahn.
Thanks, Irfan. And hearing about all our new colleagues, it's really exciting to celebrate one of our old colleagues. Steve Louie has been at Berkeley for many years, has been a tremendously valued colleague in the physics department. So it's certainly an honor for me today to present the Berkeley Citation to Professor Emeritus Steve Louie. I think most of you are aware Steve is a world-leading theoretical condensed matter physicist who's pioneered ab initio quantum mechanical calculations of electronic and structural properties of solid-state materials, surfaces, interfaces, nanostructures, and clusters. He's been a key player in advancing our understanding of novel electron correlation effects over many decades. Steve is, of course, very much a product of Berkeley, having received his PhD here in 1976, working with Marvin Cohen, who's seated with him in the front row. After brief postdoctoral appointments at IBM Watson Research Center, Bell Labs, and the University of Pennsylvania, he returned to Berkeley as a faculty member of the physics department in 1980, where he has been ever since. I first began to interact with him when I came as an assistant professor a few years later, and I always found Steve to be a warm and wonderful colleague. And in fact, I still do. I frequently run into Steve when I'm walking my dog, and he's running, I'm walking. But nevertheless, we always stop and have a brief chat when we pass each other. Steve has received a number of distinguished awards over the years, including election to the National Academy of Sciences, Sloan Fellowship, a Guggenheim Fellowship, 2 separate Miller Professorships, the DOE Award for Sustained Outstanding Research in Solid-State Physics, LBNL's Outstanding Performance Award, the Anisha Rachman Prize for Computational Physics of the APS, the Davison Germer Prize in Surface Physics of the APS, and along with Marvin, the Foresight Institute Richard P. Feynman Prize in Nanotechnology. So let me officially confer the award at this point as we celebrate Professor Louie's retirement. It is fitting that we also honor his enduring legacy with the Berkeley Citation, one of the highest awards bestowed by our institution. This award recognizes not only his outstanding scholarly achievements, but also his extraordinary dedication to UC Berkeley's mission of excellence in education, research, and public service. He is one of only a few members of the Berkeley community to receive this honor, and it is my privilege to present it to him. Steve, can you come up?
We can't move till she says go. Thank you. Thank you. Yes, let me give you the microphone. And I should also say that our Chancellor, Richard Lyons also sends his congratulations. He's unable to be with us today, but he sends.
Yeah, thank you. Thank you, Steve. I would just like to express my, real honor, real pleasure to able to receive this honor being given by the Chancellor and nominated by the department. I'd just like to say a few words of thanks to this community, the department, the Lawrence Berkeley Laboratory, and the campus. They have supported me over 52 years. I've been on the faculty for 43 years. You include my time as an undergraduate and a graduate student. I've been associated with this community for 52 years. So I feel really lucky and proud to be part of this great institution. I have a lot of opportunity to work with great students and postdocs, at the same time able to collaborate with many, many outstanding faculty members and researchers here at Berkeley. So, go Bay.
Congratulations. We'll lock it up. Don't worry. Yeah. We also have the pleasure of welcoming many staff members that have joined our ranks. And in fact, I'm going to embarrass them by putting their quotes and welcoming them. And I hope you join me in welcoming them as well. So we have with us, running our finances, Mavis Young Lau. Okay, here's Mavis. We have Ariana Castro, who has this beautiful quote that says, "The only way to do great work is to love what you do." And she is committed to strengthening equity and inclusion. Is Ariana here? Do you want to say a few words? All right. The words are here. We have Nitin Srivastava joining us as an undergraduate advisor. And his quote is, "Education is not preparation for life, education is life itself." And in fact, he wishes to focus on many things, including student transition, success, and persistence, emphasizing integrity and fostering a diverse and inclusive environment for all students. Nathan, if you're here and want to say a few words, please do so. Okay? But we welcome you. Okay? So, in addition to our new staff members and administrators, we have, of course, folks that have won awards on the staff side. In this particular case, SPOT Awards. These awards are given for enhancements to collaboration, enhancements to the ability to achieve goals, both at the individual level and within a unit, inclusion and belonging, demonstrating respect for people and their ideas and differences, innovation, using knowledge and skills and professional experience to push the boundary forward of what's possible in this institution, and mastery of a given set of skills and knowledge. And I'm happy to report that Amin Jazeri, Carlos Bustamante, Claudia Trujillo, Mari Royer, Kathleen Cooney, Marjani Jones, S.P. Munoz Whittle, Stephen Pride, Rafael, Elizabeth Takamahama Ryan, Mr. Dash, Extra Mile, Austin Hedeman, and Alex Perry have all won this award. So please join me in a round of applause. And of course, the students, you're here, right? This is the incoming class. Okay, we welcome you, right? I'm not going to read all your names. Okay? Berkeley remains a tremendously challenging department to gain admission into. We had 1,192 applicants, 44 acceptances out of that. Okay? So there were 625 experimentalists that applied, 23 were accepted, 556 theorists, 21 were accepted. And you see the different fields of physics in which they have expressed an interest. Moreover, postdoctoral researchers. we have another 2 slides worth of world-class postdocs that have joined our department. So welcome to all of you. Okay. And at that time, with this community reassembling and starting again in the fall, I'd like to reinforce things that we've spent many years working on to strengthen our community. Okay. And the idea is that Berkeley becomes Berkeley when we have a climate, right, which allows engaged citizenship, transparency in communication and other operations, a network of alumni to mentor, and recruitments, right, all across the board. And we're going to continue to build on this community by different types of events to seek your feedback, and also look at the best practices for implementing all of the lofty principles that you heard about from our speakers. And in particular, we'll have a fall department-wide discussion. This is on the 4th of October, 3 p.m. at Zoom. We'll have faculty committee plans, back to transition reception in September, increased training and support for undergraduate leaders, faculty retreat and staff committee events to address climate issues, amongst many of the things that we'll undertake during the semester. Okay. And again, to remind you that much effort was put in through a series of lectures and other events to put together a handbook of good practices and best practices for the department. So I encourage all of us to continue to refer to this book and think about how to implement it in our day-to-day operations. Okay. Physics is physics because of many, many student organizations. Some of them are their logo cloud is shown here, and they participate in all the social activities and scientific activities of this department. Okay. And our undergraduate class, these are folks that have graduated recently from us, and these are some statistics on what they will be doing after Berkeley. So we have 110 graduates in 23-24. Half of them are continuing their education in some form, and then roughly a quarter are going to work in tech, and a quarter are pursuing other types of employment. And if you look at those keywords which showed up the most in their exit surveys, these are the types of activities they're going to engage in: research assistant, software engineer, data scientist, quantitative analyst, quantum device test engineer. Folks that want to transition, I don't want to say retire, there you are. Okay, running many things, so Professor Wick Axton will be changing from one form of life to a different form of life, but hopefully we will still continue to interact with you in many ways. So maybe a round of applause for Professor Axton. At the same time, every year, this is the saddest part of the talk, of course, for me, folks that have moved on from us, and we remember 2 faculty members. This is Furqat Bardakchi, and Furqat was a professor of physics at UC Berkeley. He passed away on the 16th of March, 2024. Professor Bardakchi made seminal contributions to quantum chromodynamics and string theory. Together with his colleague and friend, Martin Halperin, Professor Bardakchi discovered a new type of mathematical structure within string theory, affine Lie algebras, which enjoyed far-reaching applications. So we rest in peace. We also remember Rainer Sachs. Ray Sachs passed away in April of 2024, very much missed by his family and his many colleagues and friends. Sachs spent the majority of his career from 1969 onwards as a professor of mathematics and physics at UC Berkeley. Unusually, he had 2 very distinct careers in science, both very successful. The first in general relativity and cosmology, and the second one in mathematics of radiation biology and carcinogenesis. So again, rest in peace. To terminate the presentation this afternoon, I wanted to actually mention just a few activities that we have upcoming in this year. There is the Physics Innovation Lab. Those of you that have walked by Physics South, you will have seen this activity outside the student machine shop. And this is now really state-of-the-art space, which is near completion, which allows undergraduates to have state-of-the-art tools for automated processing, computer-aided design, 3D printing, and really a tinker space to test out their ideas. And this is made possible through the generosity of a very generous donor and good friend, and we will have a special presentation very soon to honor that contribution. This is something that I'm also participating in at the moment, which is many years in the making. This is a task force to look at our graduate curriculum. What are we teaching? How are we teaching it? With all of these fields of physics now intersecting with each other, perhaps we can think about how to merge this curriculum together into something which is more homogeneous and has more clear expectations of what performance is like in these classes. So I'm very grateful to the faculty members and the graduate students on this committee as we undertake this work, which we started many years ago, but I hope we will bring to a far-reaching state very soon. We have a lecture scheduled on the 28th by Pablo Herrero Herrero, who will talk about the wonders of graphene, in particular putting layers of graphene and twisting them into woven silk threads like the French had in moire structures. So I do invite all of us to come to this lecture at the International House, as always, at 5:30 p.m. on the 28th. Another initiative, which is in the works at the moment, is something dubbed Quantum California, with all of the quantum activities happening in this state, both in industry and academia and at national labs. The goal of this particular initiative, and I'm thankful to Professor Steve Kahn for undertaking it and leading it for us, along with our government relation folks, in particular Michelle Moskowitz and Miguel Martinez and Joe Rafa from the VC side. We're getting together and thinking about what the state can do to invest to keep California at the forefront of quantum information science. And this involves looking at infrastructure for us, incubators for bringing industry together with academia, how to think about revitalizing the curriculum or modernizing the curriculum for this newly developing discipline, and how to train the next generation of workforce and scientific leaders in this field. Okay. So there are many intersections there, and one of the outputs that will happen very soon, hopefully, is a roadmap, a public policy roadmap, which is being headed up by Dean Henry Brady, former dean of the Goldman School for Public Policy, and we very much look forward to his stewardship in putting together a plan for California. Okay. And again, there's a village that makes all of this happen, so I wanted to thank also the leadership team on the faculty side going forward. Professor Dan McKinsey is here, will continue to serve as Vice Chair for Faculty Affairs. Professor Yuri Kolomensky will be the Vice Chair for Instruction. Professor Heather Gray will be the Associate Vice Chair for Instruction. Okay. Professor Martin White will be co-chair for faculty appointments, along with Professor Shimon Kolkowitz, who's sitting here. Okay. And our head advisors, Naomi Ginsberg and Gabriel Rubigan, will co-head the undergraduate advising sector. Dan Gehazen will continue as head graduate advisor. Professor Holger Mueller will be the head GSI advisor this academic year. And with that, I want to bring this to a close, welcome you again, and tell you there's nice things to munch on outside. Welcome to 2425.